Titration.
Assalamualaikum. My name is Muhammad Afif Danish bin Ahmad Sumri, and I will introduce my group member. First one, we have Muhammad Hazi Ifan bin Rosli, Irshad Rushaidi bin Ismail Farkuzi, Muhammad Adib Amsham bin Rosli, and Muhammad Adib bin Rozi. And this is our group member. Introduction for our topic is what is direct titration? Direct titration is an analytical method used to determine the concentration of a substance, or we call it analyte, by reacting it with a solution known concentration, titrate. The titrate is added directly to the analyte until the reactant is complete, typically indicated by a color change.
For titration, we have two objectives. First is to learn how to prepare an accurate standard solution that can be used to standardize other solution. Second is to learn the technique to prepare an acid solution from a concentrate hydrochloric and to determine the accurate concentration of the hydrochloric solution by standardization with a standard solution.
Hi, Assalamualaikum. Now I want to present the method of preparation by using direct titration. So I want to present with a flowchart technique so we can understanding this easily. So we start by preparing the standard solution of Na2CO3, or we call it sodium carbonate, and after that we rinse and fill the burette with HCl. After that, pipette was rinsed with sodium carbonate solution, and the pipette was rinsed also with 25 centimeter cubic into a conical flask. And after that, we must add metal orange indicator with 2 or 3 drops to the flask, and conical flask was placed on a white tile. Titrate by slowly adding HCl from the burette while swirling the flask. After that, stop titration when the indicator change color, like example, yellow to orange pink, and record initial and final burette reading. After that, repeat titration for concurrent titrate within 0.10 cubic centimeter cubic. After that, we calculate average volume of HCl used. HCl in this experiment is known as unknown concentration. We also use titration formula. We must use this to calculate the concentration of HCl by using the formula C1V1 over N1 equal C2 V2 over N2, where C1 is concentration for non-concentration, and V1 is volume non-concentration, and N is moles for non-concentration, and C2, V2 and N2 is refer to unknown concentration. That's all for me.
Alright, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Adib. I'm going to explain to you about selecting indicator. The content of selecting indicator have a type of titration. Example, pH at equivalent suitable indicator and color change. The first one is strong acid and strong base. The example we use that HCl and NaOH solution. The pH at equivalent is at 7 and the suitable indicator is bromosimol blue. The color change is blue to yellow. The next titration is weak acid plus strong base, such as CH3COH and NaOH. The pH at equivalent point is pH 8 to 10. The suitable indicator is phenolphthalein. The color change is colorless to pink. Next, we go to strong acid plus weak base, such as HCl and NH3. pH equivalent is 3 to 6 pH. Suitable indicator is methyl orange and the color change is red to yellow. Next, we go to weak acid and weak base. This type of titration is rarely used and difficult to resolve, and suitable indicator is none, and the color change is not have. That's all from me. Go to the next part.
Alright, now this slide we have a clear comparison between the endpoint and the equivalent point in titration. First, for basic definition, the endpoint is the point at which the reaction is observed to be complete. This is based on the what we see, usually a color change. Meanwhile, the equivalent point is the point at which the reaction is actually complete from a chemical standpoint, where the exact amount of reactant have reacted. Next, practical use. The endpoint often happen very close to the equivalent point. It's the point that tell the analyze to stop adding titrant and record the volume. So it's a practical visual stopping point. On the other side, the equivalent point is the point at which a stoichiometric amount of titrant is added to the analyte. Means it's the exact ratio needed for complete reaction. Finally, indicator and accuracy. For the endpoint, the selected indicator should change color very near to the equivalent point. This is physical observation that tell us to stop. Theoretically, at the equivalent point, we can calculate the precise amount of titrant required to react exactly with the analyte. So, the endpoint is what we see, guided by an indicator, while the equivalent point is the exact chemical completion point. Good choice of indicator help ensure that the endpoint is as close as possible to the equivalent point, giving us accurate titration result.
There are many factors for success titration for experiment. There are six that I found for direct titration. The first one is accurate measurement. Use properly calibrated burettes or pipettes for precise volumes. That's how you get an accurate measurement. And the second one is proper endpoint detection. You have to choose a suitable indicator that changes color sharply at the equivalent point. The third one is consistent mixing. You have to swirl the flask continuously to ensure thorough reaction between titrant and unlike. The fourth one is slow addition near endpoint. Endpoint. Add titrant drop by drop when nearing the endpoint to avoid overshooting. The fifth one is clear and clean glassware. Uh, we have to ensure all equipment is clean to prevent contamination and false readings. And the last one is to repeat the trials. Perform multiple trials to obtain consistent and reliable results.
Next, in calculation in direct titration, we use formula molarity, which moles over volume. Use M1V1 equal M2V2 for 1-1 stoichiometric reaction. For non-1-1 reactions, apply stoichiometric ratios. This ensures correct concentration determination. Example, determine the unknown concentration of acetic acid pH calculation at 10 ml addition of base before equivalence point. For the titration of 50 ml of 0.05 molarity hydrochloric acid with 0.10 molarity sodium hydroxide, calculate the pH after adding 10 ml of sodium hydroxide. Step 1. Write the reaction. Hydrochloric acid plus sodium hydroxide react to form sodium chloride plus water. Step 2. Find the initial moles of hydrochloric acid. 50 ml multiply with 0.0500 mole per liter equal 2.50 multiplied with 10 powered negative 3 mole hydrochloric acid. Step 3 is find the number of moles of sodium hydroxide supply. 10 ml multiply with 0.1000 mole per liter equal to 1.00 multiply 10 power negative 3 mole sodium hydroxide. The moles of hydrochloric acid that react are equal to the moles of sodium hydroxide added since 1 mole of sodium hydroxide interacts with 1 mole of hydrochloric acid. For step 4, we use formula initial minus excess hydrochloric acid. So 2.50 multiply with 10 powered negative 3 mole hydrochloric acid minus 1.00 multiply 10 powered negative 3 mole sodium hydroxide equal to 1.5 multiplied with 10 negative 3 mole hydrochloric acid. Step 5, we find total volume of solution. 50 ml initial acid plus 10 ml added base. So we get 60 ml or 60 multiplied with 10 negative 3 liter solution. Next, we find the concentration of hydrogen ion that state. Hydrogen ion, we use formula 1.5 multiply 10 negative 3 mole over 60 multiply 10 negative 3 liters. So we get 0.025 molarity. For step 7, to find pH, we use formula pH equal to negative log hydrogen ion equal to negative log 0.025 molarity equal to 1.60. So the pH is 1.60 pH. This is example question from the titration. There are two methods to find it. First, method compare from equation. Another one is method formula. This is our references.